In the previous examples, we were looking at continuous functions, meaning there were no holes, breaks, gaps in our graph. Now in examples 5 and 6, we have cases where there is some point of discontinuity, and we'll see how that impacts some of the statements that we were writing in those previous examples. In example 5, part A, we still want to start off by identifying intervals of increase and decrease. This function is decreasing everywhere except at that point of discontinuity. So there's no intervals where it's decreasing, increasing. But we can say that our function is decreasing on 2 intervals. First, from negative infinity to negative 3, since that's where this vertical asymptote occurs. And then we need to put in a break. So we'll put in a union symbol and then continue that interval from negative 3 to infinity. The rounded parentheses means that number itself is not included as part of the interval because our function can never hit a value of x equals negative 3. So we have that break, that gap in that otherwise continuous interval. Then we want to look at where our function is concave up and concave down. Our function is making this bowl shape on the interval from negative 3 to infinity. And from negative infinity to negative 3, it's making this upside down bowl shape. Keep in mind if there's not enough of the picture or enough of the curve to kind of visualize that, you can always just imagine drawing the rest of that cupper bowl shape. But as long as we can understand whether that curve is opening up or opening down. Next, we want to consider the one-sided limits at this vertical asymptote. As x approaches 3 from the right-hand side, our function f of x is approaching positive infinity. And as we approach negative 3 from the left, our function value is approaching negative infinity. We want to determine the end behavior of this function. In this case, as x goes to either positive or negative infinity, we're approaching this horizontal asymptote at y equals 2, not x equals 2. So we could say that the limit as x approaches infinity of f of x is equal to the limit as x approaches negative infinity of f of x, which are both equal to 2. And then either from looking at the graph or understanding the information that we've established in parts C and D, we know that we have a vertical asymptote at x equals negative 3 and a horizontal asymptote at y equals 2. So keep in mind we're building up to the idea of being able to take the information to construct the graph. So we want to note how these ideas relate, how the picture relates to the numerical information, the limit-based information, to understand where we have those asymptotes occurring. In example 6, again, we want to identify intervals of increase and decrease. This function is increasing from this local minimum up to infinity. That's at about x equals 1.5 to infinity. And our function is decreasing on the interval from negative infinity up to this point discontinuity at x equals 0, union 0 to 1.5, where that local minimum occurs. We need to make sure we exclude that value at 0 since the function is undefined there. And then we can look at concavity. In this case, our function is always concave up since we have this cup or bowl shape, but we still have to exclude that point A, where x equals 0. So we'll say this is concave up on negative infinity to 0, union 0 to infinity, and there is no interval where our function is concave down. We can consider the limit as we approach that discontinuity point. As we approach 0 from the right, we're approaching a function value of 3. As we approach 0 from the left, we're also approaching a function value of 3. Since the function is undefined at x equals 0, but the two one-sided limits are equal, that means that the limit as x approaches 0 of g of x is equal to 3 and tells us that we have a point discontinuity. Then we can look at the end behavior of this function. In this case, it's headed off to positive infinity in both directions. And we can identify all asymptotes, which in this case would just be d and e does not exist. This function has a point discontinuity, but no vertical or horizontal asymptotes.